Hello, everyone. Once again, my name is Lindo Mamba. I'm Boma's assistant, and I'll be quickly taking you through our ongoing research where we're looking at the Aqueous application of Imazalil and alternatives in Aqueous solution for Imazalil and alternative for green mold control. Thank you, Eugene. Okay, I'd like just to for us to go through a quickly reminder on the Imazalil background and Imazalil status update. Our problem began back in 2018 after the EU requested to drastically lower Imazalil MRLs. That resulted in a review where a gap in the toxicology dossier was discovered, which concerned Imazalil metabolites. The good news is Janssen is on track to submit required data within that time frame, which is early next year. But for now, the new Imazalil MRL still stands since last year. Closure of the data gap will mean that we can still use Imazalil until 2029. So this brought about this research, which is still ongoing. The project was launched back in 2019 to investigate possible Imazalil alternatives. And the Aqueous application, application side is co-funded by the PHI. So we are currently looking at all registered fungicides, namely azoxystrobin, fludioxanil, orthophenylphenate, pyrimethamine, and thiabendazole. These fungicides are compared to Imazalil and water. So our main focus is looking at the curative ability and sporulation inhibition in deep, where we look at application time after infection, fungicides, so solution temperature, and residue consent with those results. But before we continue, I would like to mention that since this is an ongoing study, we're not making any recommendations. So how did we get about that? Okay, so we used the Penicillium digitatum culture for this study, where as a inoculum at a spore concentration of 10 to the 6 spores per mil. For curative ability, we wounded the fruit using a dipping tool, using a wounding tool where we dip the tool in the suspension and making 4 equidistant wounds per fruit on the sides. And then for sporulation inhibition, inoculation was done by injecting 0.2 mils of the inoculum into the deep tissue of the fruit. After inoculations, fruit were dipped in our in-house deep at treatment temperatures 25, 35, and 45 degrees. Treatments were done 8, 12, 18, and 24 hours after inoculations to test for curative ability. We also looked at the fungicides in combination at treatment temperatures 35, 8 hours after inoculations, and all trials were repeated. For this study, we are aiming at studying all the fruit types, and what we have done so far is navel and lemon, which were treated at 24 hours after inoculations. We managed to do Valencia oranges, which were treated at 8, 12, and 18 hours after inoculations. And those were only standalone fungicides. Luckily, we managed to cover all fruit types for combination treatments. So if, oops, sorry. Okay, then after that, the fruit were incubated at 25 degrees until 80% of the rot was observed on the control fruit. So just to mention how the results are going to be presented, the disease incidence was rated using a UV light, and results presented here based on average incidence control in percentages. Sporulation results were subjective to a rating score of 1 to 6, where we assess the development of green or gray spores which are capable of infection and multiplication. At a rating score of 1, that's where we see absence of green or gray spots. So if we just quickly look at the results, this slide shows results on the navel fruit treated 24 hours after inoculation. The vertical axis shows The vertical axis shows the percentage control, and the horizontal axis shows the treatments and solution temperatures. So we are looking at the curative ability of a fungicide that at least gave us 70% control. Comparing alternatives to, okay, sorry, I forgot to mention, and then on the first two treatments are our water and Imazalil, which is our positive control. So comparing our alternatives to the Imazalil, which is known to have good curative action 24 hours after infection, we see here that our OPP did as good as Imazalil at 45 degrees Celsius. It also gave us good control at 35 degrees. And here we see that azoxystrobin and fludeoxonil didn't do much at 24 hours. Quickly looking at results on lemons. On this slide, we see that parametanol also did as good as Imazalil at 45 degrees Celsius. It also gave good results at 25 degrees. And again, fludeoxonil and azoxystrobin didn't do well. While we were racing the season, we couldn't manage to test OPP on lemon, which is what we're going to be currently doing this year. Okay, then from these results, after looking at the previous results on the azoxystrobin and fludeoxonil, we decided to just take a look at their curative ability at different times after inoculations. So results shown on this slide, the results are shown on this slide, and we managed to work on the Valencia oranges, as I mentioned before. And again, on the vertical axis shows the percentage control, and the horizontal axis are our treatments at different temperatures, hours after inoculations. Here we see azoxystrobin doing well throughout the treatment times, and fludeoxonil doing well mostly at 45 degrees at 8 hours after inoculations. On this slide, we see the same trend at 12 hours, but showing good control at 25 degrees Celsius compared to 8 hours. And then lastly, the same trend is observed at 18 hours, where good control was achieved at 45 degrees Celsius. Overall, we see an increase in percentage control at 45 degrees, even on the water controls, which is interesting, and this is also giving us some more avenue to study. Just to quickly look at combination results. These slides show that show results on combinations where we did when they were tested at 35 degrees and 8 hours after inoculations on the navel orange. The vertical axis shows percentage control, and the horizontal axis show combination treatments. The first two treatments are our controls as well, which are water and Imazalil. Here we see fungicides in combination giving great control, but only fludeoxonil and OPP in combination didn't give good results. Combinations are actually doing great control, doing a great control on lemons, where you see everything is above 70% control, and also on mandarins, we see a very, very good performance of all the combinations. Okay, for sporulation results, only TBZ and propiconazole in combination and pyrimethamine and fludeoxonil in combination showed very, very good sporulation control. No other combinations as standalone products or temperature could inhibit sporulation. So the take-home message from this study so far, we see that no standalone fungicide measures up to Imazalil unless used at high temperatures. We also see a fluctuating control in different fruit types, which may not be practical in terms of residues allowed. Because of different modes of action, maybe that is why combinations gave us good results, which is what we're going to study as well in future. So we are currently looking at residues concerned with all of those controls that are just presented now. Lastly, I will again like to mention that this is still an ongoing study. Therefore, we are not recommending anything as yet. So yeah, that's all from me. Thank you very much.